All right, let's go. So,
Hello. I'm sorry.
hey,
I'm sorry. I just have one question.
mhm.
Again, I just want to know where could we get the recorded videos again?
When you go into Blackboard, now I send them in an email, and I put that email in your campus announcements. I mean, Blackboard announcements.
Okay.
So if you go to Blackboard announcements, if you didn't see the email when I sent it, if you go to Blackboard announcements, it'll be class lecture links. So every week you should get an email or a class announcement that says class lecture links, and you'll be able to click on those. There'll be YouTube videos.
Okay.
All right. All right. Somebody said they'll send them to you. All right. That's cool. That's cool. All right. So 7.4 properties of triangles. So similar triangles, they're similar objects that have the same shape but not necessarily the same size. And of course, just like any other time, I've already written this stuff out. So if I scroll up too fast, most definitely let me know. All right, so the properties of similar triangles, the ratio of corresponding sides will be equal. We'll talk about what that means when we get actual examples in front of us. The ratio of corresponding heights is equal to the ratio of corresponding sides. Then the measure of corresponding angles are equal. See if I can erase this without erasing actual triangle. Now, so just an example of two triangles that are similar. So when we talk about the ratios of their sides being equal, we look at this bottom line, AB over DE, that reduces down to 1/3. We look at BC and EF. Once again, that reduces down to 1/3. Put that 3/9, it reduces down to 1/3. And then looking at AC over DF, that reduces to 1/3 as well. And so that's what we're talking about. The ratios of their sides would be equal. All right, questions on that before we go to an actual example? Just showing you the relationship of similar shapes or similar triangles in this case, and how their sides, the ratios of their sides would be equal.
Hey, scroll back up.
Hold on, I know you ain't talking to me like that. Okay, hold on, just messing with you. Rude. Well, you one of the ones that just came in late.
No.
But yep. Not a problem though. I'm just messing with you because I can. Not a problem at all. Let me see what's going on here. All right, let me know when I can scroll up.
You scroll.
All right, thank you. All right, so let me erase some of this stuff though. All right, so we have these two similar triangles, ABC and DEF, and they want us to find FG. So you notice that they give us the height of the smaller triangle, which is 4, give us the base of the smaller triangle, which is 8. Then they give us the base of the larger triangle, but they do not give us the height of the larger triangle, and that's the one we want to find. So remember, the ratios of the heights and the ratios of the sides will be equal. And so that's what I set up right here. I got AB over DE. And then we're looking at CH, which is our height over here, over that unknown. And so you just need to establish how you want to set them up. If you want to do small triangle over large triangle, or large triangle over small triangle, just make sure you stay consistent in how you set up your proportion. So both of these are my small sides, and then the ones down bottom are large sides. All right. Before we go any further, questions on the setup and why I chose what I chose. Once again, I chose small over big. You can do big over small. Doesn't matter. It's up to you. Just have to stay consistent with how you set up your proportion.
Can you scroll back up like an inch?
Like, you want to see that last one?
Right there.
Or?
Yeah.
Okay.
Missed the last part. Okay, thank you.
Mm-hmm. All right, so the proportion will be 8 over 12 equal to 4 over x. And to solve proportions, we can always cross multiply. Take your denominator up to the opposite numerator. And that will set up this relationship of 8 times x equal to 12 times 4. And then we can solve for x by dividing by 8. And x will be equal to 6.
So I'm just making sure we can, never mind. So seeing the height was the same thing, was the same measure. Because I thought we was trying to find the height.
Now, hold on. Now, let me make sure I understand what you're asking now. So you said what as far as is the same measure?
We were looking for the height, but I'm just making sure that like the angle C wasn't equal to the height.
Oh, no,
That's
no, no,
all.
no. See, the height is right here. That's FG, going down from F to G.
Okay.
All right, did that answer your question?
Yeah, we were looking for the height of the other triangle.
Yes, yes. All right. So make sure you're okay with copying whatever, everything before I move on.
For the questions on WebAssign, I know from like previous lessons that you taught, some of the questions on WebAssign are like really difficult, and it's like what you teach aren't the same as some of the questions on WebAssign.
All right, well, bring them to class. Now, you remember, you don't have to wait until class to ask me questions. You can always, email me or if you want to set up a Zoom session, we can talk about them. But, next class, that's why I mentioned that we'll have a review day that you can bring those questions to class and we can talk about them.
All right, thank you.
Yeah, not a problem. And I would like to challenge you and say that what I teach is on WebAssign. Thank you very much. But we'll find out. We'll see what you talk about. And then go from there. All right. Questions before I scroll up? Everybody good? Everybody good? All right. But yeah, and I will say this, there is something to what you're saying as far as from the aspect of, I can't go over every single scenario in the lecture. So there will be things that you would be expected to take from what I've given you and extrapolate that to what they're asking of you. So there'll probably be some things that they're expecting you to pull from the examples, because the examples that I give you are the examples from the book. And so even when the book gives you these examples, some of them, they're really thinking, okay, now take what I've done here in this example and apply it to this problem. So it should be a little different. And but like I said, that's not a problem at all. We'll either, you'll hit me on an email and we can, set up a separate session, or you bring it to class and, we'll talk about them. And I think other people can benefit from your questions as well. So yep, not a problem at all. If we have some time after this lecture, we can, even cover some of your questions if you have them already ready. If the three angles in one triangle are equal in measure to the three in another triangle, then the triangles are similar. So this is just a way that you can tell if you have similar triangles. If you have three angles that are equal, the three angles in one triangle equal to the three angles in the other triangle, then the triangle is similar. Then if two angles of one triangle are equal in measure to two angles of another triangle, then the triangles are similar. So in other words, remember that when you add up all of your angles in a triangle, they equal to 180. If you already know that two angles are equal, then that means that third one is going to be equal as well. All right, so that's what that is saying. So that means that all three of them, once again, will be equal. That means you have similar triangles. And so that's all this little diagram is saying right here, is that, that one slash represents that those two angles are equal. The two slashes represent that the other ones are equal. So if those two are going to be equal, that means the third one has to be equal. And so that means you have to have similar triangles. All right, scroll up. And here in the red, I was just mentioning what I've already said, that the three angles in a triangle will add up to give you 180. All right, can I scroll up? Scroll up. All right. So in this next example, in the figure angle B and angle D are right triangles. Right angles, excuse me, not right triangles, right angles. AB is 12 meters, DC is 4 meters, and AC is equal to 18 meters. Find the length of CO. So let me erase some of this stuff. This is not what was up here.
Can you scroll up?
Yeah, give me 1 second. I'm trying to erase this stuff so we can walk through it. How far you want me to go up?
Yeah.
Right there. All right, you scroll up, we're good to go. I guess we're good. All right. So, like I said, in this figure, angle B and angle D are right angles. AB is 12 meters, DC is 4 meters, and then AC is equal to 18 meters. Find the length of CO. All right, so this is what they've given us. They tell us, like I said, A and D are right angles. And I'm going to erase this right here. And they tell us, well, before we go there, we know that these are going to be similar triangles because we have the angles of B and D to be equal. But don't forget we have vertical angles right here. That means these are equal. So, and we just saw the statement that said, if you know that two angles are equal, that means the other one is equal as well. And that means we have similar triangles. So we're just throwing it out there. We have similar triangles. And remember, the only reason we can go and set up a proportion is because we have similar triangles. All right, so once again, I'm going to set up my proportion. Big over small, small over big. So small triangle over big triangle. Side C, CD and AB. Let me write it like this. CD and AB correspond to each other. And then I want to know the length of CO. So what I would do is use CO, which is right here, and that corresponds to AO. So this is the proportion I'm going to use to set up. Now, they give us the whole line. Let me get a brighter color. Oh, I could have just used it. Yep, do this. So they use the whole line of AC and they tell us it's 18. But we don't want the whole line. We just want CO as far as figuring it out. We need to do that. So what we can do is that we can let CO be equal to X. And if the whole thing is equal to 18, we can let this be 18 minus the X. So whenever you're given the total line like that, you can let one piece be X and then the other piece be the total minus that X. So 18 minus X. So that's why we would have X here and then 18 minus X on the bottom. Questions on that setup, make sure we're okay. So from there, cross multiply. So we have 4 times 18 minus x, and then 12 times x. So once you distribute 4 times 18 minus 4 times x, which is 4x, equal to 12x. Add 4x to both sides. That'll be 72 equal to 16x. And then when you divide by 16, x equal to 4.5. And that x, remember x we said was going to be equal to CO. And that's what we were looking for. Questions. Now scroll up. Very good. All right. So next one, congruent triangles. Congruent triangles have the same shape and same size. We have a couple of theorems. I believe we have 3 of them set up. Yeah. A couple of theorems to copy down. If the 3 sides of the triangle are equal to the corresponding 3 sides of another, then the 2 triangles are congruent. So it's the side theorem. If all 3 sides are equal, then the triangles are congruent. Next one, side angle side. Let me know if I'm scrolling up too fast.
What does that say when it says 3 sides of the triangle are equal to the
Corresponding.
Okay, thank you.
Yeah, no problem. I didn't write that all the way out. Let's see if I can squeeze it in there though. All right. So the next one, side angle side theorem. If the 2 sides and included angle of one triangle are equal to that of a second triangle, the 2 angles are congruent. I think I got a diagram for it. Yeah. So I'll pull up in a second. All right. Let me do it like this. So just a generic drawing of what they mean, talking about two sides and the included angle.
Can you scroll back up?
Yep. Let me know where to start. Right there. Or... All right, can we go up now? Good. Okay. So the next one is angle side angle theorem. The two angles, and let me clean that up. And the included side of a triangle are equal of another, and the two triangles are congruent. So we're talking about the angle side and then that angle. So two angles and their included side. If they're equal, then the triangles are congruent. All right, let me scroll up. All right, so first example, dealing with this type of thing, they ask us, are the triangles congruent? So don't forget, the only way that we can establish that they are congruent is if it fits one of these three theorems, either side, that means all the sides are equal, side, angle, side, two sides and their included angle are equal, or angle, side, angle, that's two angles and their included side are equal. If we can't use those three, then we can't say that these triangles are congruent. So here we have, are the triangles congruent? And the only information that we have is that we have all three angles are equal. All right. And so these triangles are not necessarily congruent. They do not meet either theorem or do not satisfy either theorem. So they do not satisfy either one of the theorems. All right, any questions on that first one?
Only the one on the right isn't congruent?
No, it's the whole thing. I was just pointing to that example. So in other words, they're not congruent to each other. Yeah, they're not equal to each other. Yeah. I was just trying to separate that from the next example. Didn't want to mix up notes. All right, scrolling up. All right, so the next one, they give us the information that we have 16, 18 for our sides in both cases. And then in between those sides, we have 60 degrees. So these triangles are congruent because of side angle side theorem. Two sides and their included angle. All right, scrolling up. I can write that better. Pythagorean theorem. So your Pythagorean theorem, it's only for right triangles. So it's only for right triangles. A squared plus B squared is equal to C squared. Those are our sides, A, B, C. Or A and B, they're considered legs, and C is the hypotenuse. So you could look at it as leg squared plus leg squared equal to hypotenuse squared. So, like I mentioned, it's only used for right triangles. C is always the hypotenuse. C is always the longest side and opposite the 90-degree angle. And C is always on the side of the equation alone. All right. All right, and I already mentioned A and B are interchangeable. Any questions on that before we use it? Questions at all? All right. So I want to find the missing side. They give us 5 centimeters for one side, 12 centimeters for the other. And then the side that's opposite the 90 degrees, that's the missing side. So that would be C. So don't forget, C is always opposite the 90-degree angle, and it's always our longest side. So once we've done our calculation, if C is not larger than 12, then somewhere we went wrong. So go ahead and plug those in for A and B. So that'd be 5 squared plus 12 squared equal to C squared. So 5 squared is 25, 12 squared is 144. And so what we would come down to is 169 equal to C squared. And then if you were to take the square root of both sides to get the square off of that C, we will have C equal to 13. All right. Questions? Any questions? All right. Let's see. Oh, that's the last one. Okay. So, questions on that. So it would be some variation of that. If they ask you to find the missing side, you plug in the pieces accordingly, and then solve for the missing side. And that's it for 7.4. Did anybody have any questions on anything I said today, or questions on anything from chapter 7 period? We had a few, but I don't know if you had your questions ready for today. Anybody?
I guess I have a question for the test. Will we be able to have like the formula sheets or anything like that? Especially for like the kilograms and all that stuff.
Well, yeah, well, see, chapter 7's test, you'll be able to do that on your own. So you'll be able to look up whatever it is you want to look up. There's no way for me to govern that anyway from letting you take it, at your own pace or at your own leisure. So yeah, you can use whatever you like. As long as you know how to use them, you'll be in a good place. So you can look up the formulas.
Okay, thank you.
Not a problem. Thank you for asking. All right. Anybody else? Anything else? Anybody else? All right. So I know, listen to one of your classmates that will have some questions on next class, come from at least one person, but most definitely take that time and bring your questions so we can take care of everybody's issues with certain problems. And even if you don't have any questions, most definitely make sure you show up, because their questions may help you with something that you may deal with or going to deal with as you go throughout your chapter 7's content. So once again, next class we will be reviewing. I will be answering any questions that you bring to the table. And then also we will establish what our due date will be for all of chapter 7's content. All right, any other questions before we close out today?
No, so this is the end of 7.4 right here?
Yes.
Okay. Yeah, I'm pretty cool. I don't know. I don't know what happened last class, but somehow my notes seem very like minimal. But you said that you posted your videos on YouTube, so that's I'm gonna put the pieces together.
Now, they may not have been, it just depends on what your definition of minimum is or minimal is, because really we did perimeter, area, and volume. And those pretty much are, plugging in the formulas, knowing what the perimeter formula or area formula is, or volume formula for the shape that you're dealing with, and then plugging it in and then calculating. So there may not have been much, depending on what your definition of minimal is, you know what I mean? So,
Yeah.
take a look at it. And, well, just like I mentioned to one of your
Yeah.
classmates.
So I haven't even got to that part on the homework yet to even use the notes. So
Okay.
I'll
Okay.
see when I get there. But
Yeah.
yeah, that's why I said no questions. But thank you. I
Okay.
appreciate
Yeah.
it.
Not a problem. Not a problem. So once again, guys, if you see something in WebAssign that you feel like, either I missed or didn't cover, or you just had a general question on, feel free to bring it to class. I don't have a problem going over anything. We'll knock it out from there. If I, mess with you, I just do it because I can. Other than that, make sure you bring your questions. I have no problem with answering any questions that you bring to the table. So other than that, you guys have a great day. Be safe, and I will see you on Thursday.
You too. Thank you.
All right. Thank you.
Have a good one.
Do the same.